Hi guys, so today we will be starting another very important topic after we have already discovered the ways in chemistry that how to identify cations. Now it is time for us salt ka pura completion. A salt consists of a cation and an anion, right guys? So what is a salt? Salt is a cation. So cation, let's take C, and there is an anion. So salt has cation and anion like this. So cation we have already done, we have identified. Now it is time for us to have our new topic, that is identification of anions. ठीक है ना? Identification of anions. So one by one we are going to identify some important anions which are very important from examination point of view, not only in practical chemistry, in various paragraph type questions often asked in various schools and competitive examinations. We have to go through this very minutely so that this little bit of knowledge helps us in achieving greater heights. Okay, so we shall start with, okay, we should put the heading first, right? Heading तो डालना पड़ेगा. Identification of anions. Identification of anions, very important part. Okay, so first of all we are going to take a very simple anion, that is carbonate anion. ठीक है ना? So carbonate anion, CO3 2 minus, right? This is the carbonate radical. So we'll consider one of the carbonate, whichever we want. So let's take the simplest carbonate, that is sodium carbonate. Okay, so just know one thing, we are taking this as a sample, but remember, while you are doing practical chemistry you don't know whether it is carbonate, right? So you are testing for carbonate, you are just testing कि ये carbonate है या नहीं है. So we are going to find out carbonate है या नहीं है, तो देखेंगे. So कैसे? So first of all, in the salt what I'll do, I will add dilute H2SO4. ठीक है? So whenever we are talking about dilute H2SO4, remember it's an acid, and if this is a carbonate, let's just assume, because we don't know whether it's carbonate, if this is a carbonate, then Na2CO3 will react with H2SO4, and what should it form? Carbonate plus acid. Remember this reaction, remember this as a mathematical formula. Carbonate के साथ acid का reaction होता है. So you will get salt, water, carbon dioxide. Any carbonate with acid, salt, water, carbon dioxide. ठीक है? So salt किस किस का बनेगा? ये आपका कैटायन है, ये आपका एनायन है. इधर पे सोडियम लिखना, इधर पे सल्फेट लिखना. सोडियम का वैलेंसी 1, सल्फेट का 2, क्रॉस मल्टीप्लाई, राइट the formula like this. ठीक है? Make it logical, make it mathematical, don't make it complex. Okay? Formula. You have formula for calculating the formula. Right? हो गया, आपका salt बन गया. Now you have to have only CO2 plus water. Any carbonate will react with any acid to form salt plus water plus carbon dioxide. So whenever carbon dioxide is evolved from any solution, we get a characteristic observation, that is brisk effervescence. ठीक है? This is a characteristic observation. Now you know this brisk effervescence can come with carbon dioxide and also sulfur dioxide. But remember, if it is a sulfur dioxide, you will get a pungent odor, but you are not getting any odor in case of carbon dioxide. So if it is a carbonate, first of all you will not get any odor. Next, what test you should do? To ascertain this is carbon dioxide, what will you do? You will, suppose this gas is getting evolved, so you are going to pass this gas through lime water. What? Through lime water. And lime water will turn milky. If it is carbon dioxide, lime water will turn milky. How it will do? Lime water means calcium hydroxide. ठीक है? And calcium hydroxide will react with CO2 to form calcium carbonate. This is nothing but a precipitate. This is basically marble and nothing else. or chalk, the chalk that I use for writing on the blackboard. The same thing, and here I will get water. Okay, reaction is already balanced. So this is how you get the lime water milky. The problem is, even if it was sulfur dioxide, still it would have turned milky. Okay, even if it was sulfur dioxide, it would have turned milky. But first I have already checked brisk effervescence with no odor. Brisk effervescence with no odor, so definitely it should have been carbon dioxide. But to double check whether it is carbon dioxide or not, please pass this CO2 through acidified K2Cr2O7. No color change. Or acidified KMnO4, no color change. In both the cases there is absolutely no color change, and that is the beauty of this chemistry, right? That is the beauty. No color change over here, carbon dioxide. No pungent odor, carbon dioxide. Brisk effervescence, carbon dioxide भी हो सकता है, सल्फर डाइऑक्साइड भी हो सकता है. अभी देखो पूरा गारंटेड है, इट मस्ट बी अनकार्बोनेट. गारंटेड है, इट मस्ट बी अनकार्बोनेट. ठीक है, सो कार्बोनेट का टेस्ट हो गया. If it is a carbonate, this will give this observation and you are 100% sure definitely this is carbonate. ठीक है, so this is test number 1. And test number 2, there is another test. So another test is BaCl2 test. Okay, so what will happen with BaCl2? Let's see. So if I use BaCl2, I'll number 2 test. I am adding BaCl to barium chloride, very important reagent in inorganic chemistry, very important reagent. So there are some important reagent you need to note down. So one of them is barium chloride, AgNO3. So we are going to note down in this lecture what are the important reagents that we get. So and we are going to keep it in our copy so that we can refer it any time that these are the important reagent. Photographic हो जाना चाहिए, ये important reagent है बस. BaCl2, add BaCl2 with Na2CO3. What does it form? Let's see. It's a simple reaction. Simple reaction. क्या reaction है? Double decomposition reaction. Barium with carbon. अभी barium लिख दो, कार्बोनेट लिख दो. बेरियम का 2 वैलेंसी, कार्बोनेट का 2 वैलेंसी, क्रॉस मल्टीप्लाई करो, 2 2 काट दो, सो क्या आ जाएगा? बेरियम कार्बोनेट. सो फर्स्ट ऑफ ऑल इट इज Ba2CO32, राइट? बट दोनों में 2 है तो आई कैन रिमूव दिस, राइट? आई कैन डिवाइड इट विथ 2 एंड आई कैन रिमूव दिस. सो बेरियम कार्बोनेट प्लस Na एंड Cl. Na का वैलेंसी 1, Cl का वैलेंसी 1, क्रॉस मल्टीप्लाई करो, NaCl. सो NaCl है ना, NaCl. How did you get it? I got it like this. Na and over Cl. Na का valency 1, इसका ऐसा क्रॉस मल्टीप्लिकेशन NaCl. After that I balance it. Simple. ठीक है, simple balancing है. So in this, see here it forms a white precipitate. ठीक है, here it forms a white precipitate. You put this in HCl. ठीक है ना, you put this barium carbonate in dilute HCl. क्या है? This dissolves in dilute HCl. ठीक है, you can write down, this dissolves in dilute HCl, because see at the end of the day it's again a carbonate, and carbonate will react with dilute HCl, that's an acid, to give you salt water plus carbon dioxide, right? So it is going to dissolve in dilute HCl. Again it is proved that it was a carbonate. Again it is proved that it was a carbonate. यही अगर salt है, if this is the salt and I take a pinch of this salt, go for flame test, what will be the color, guys? Golden yellow, sodium ion. And I know it has cation sodium, I know it has anion carbonate, sodium carbonate. I can get the total formula. So cation तो हमने पहले कर लिया, अभी anion भी कर लिया. चलो, तो this is how to identify carbonate. ठीक है, so please write down. Hello guys. So we have already studied about the tests of radicals. At least we have started it, right? The previous video that you have seen, it was a very short video just to give you an idea, the basic understanding of radical testing. We started with carbonate. Our next radical, which will be very similar to carbonate, will be sulfite radical. So we will be talking about sulfite radical. How to test sulfite radical. So sulfite radical, if you see, we have to first assume any sulfite to make our understanding clear. So we will take Na2SO3. So actually in case of sulfites, the tests are quite similar as in case of carbonate. So sulfite, you take first of all you will add, you can add dilute H2SO4 or dilute HCl. So I will add dilute HCl this time. So I will get, see this is a sulphite, this is a dilute acid. What will you get? You will get a salt, water plus sulfur dioxide. Okay, so salt will be sodium chloride, water and SO2. Okay. So in this case, to balance it, definitely I have to put it to NaCl and the job is, I guess, done, right? The difference between this reaction and the reaction we have done in case of carbonates is this one. There we had got CO2, now you are getting SO2. In smell, you get a characteristic difference. This will also give brisk effervescence. Okay, but there is a characteristic smell which you need to know. In case of sulfur dioxide, you get a pungent irritating smell which is like the smell of your burnt matchstick. Okay, so if you want to relate that smell is like burnt matchstick smell. Okay, so you now can guess or you can do the experiment yourself with proper caution. You take that matchstick, try to light it, and then after it just extinguishes, just take its smell a little bit. So you will see there is a irritating smell and a characteristic smell. That smell you can say that is the smell of burning sulfur. So that smell of burning sulfur is characterized by SO2. ठीक है ना, तो that is clear है, SO2 है. Other than that, even if you add lime water in this also, so then also you will get CaSO3 plus water. So again you will get milky solution of the lime water. So lime water will turn milky. So here there is no difference in between carbon dioxide and SO2. Next is, if you pass this SO2 through acidified KMnO4, concentrated H2SO4, then this will change color. So pink color decolorizes, you can write pink color decolorizes. So this KMnO4 is having pink color and this gets decolorizes. Detailed reaction we will do in other part. We are not going to do detailed reaction of SO2 and KMnO4 concentrated H2SO4 in this part. Next is, if you give in this K2Cr2O7 concentrated H2SO4, then this K2Cr2O7 is of orange color. This color changes to green. So you will write orange color changes to green. Orange color changes to green. So if you see, while we talked about CO2, there was no color change in these two tests. But while we are talking about SO2, there is color change. So whenever this brisk effervescence is coming out with a pungent odor, I have an idea, this is SO2. I pass it first through lime water, I get milkiness. So this can be SO2, CO2. So after that, I will use any one of the solution. If there is a color change like this, then definitely it is SO2. If there is no color change, you know it very well, it will be CO2. Okay? So that is about sulfite radical. Next radical we are going to do is sulphide, that is S2 minus. Okay? So we will take one of the sulphides. So you can take FeS. Okay? So in case of sulphides, what kind of reagents we do use? First of all, you have to have a reagent that is giving a precipitate. You see, everywhere we have taken a reagent which gives a precipitate with the anion. So this is sulphide. So which sulphide is forming precipitate that is insoluble in water? First thing is this. So see, lead sulphide is black and it precipitates in water. So it doesn't dissolve in water. So lead sulphide is black. So any compound with lead I can use which is soluble compound. Okay, na? So generally there are two solutions that we use. Number one is lead nitrate. So if you use lead nitrate, if it reacts with FeS, double decomposition reaction will take place. So this will be PBS and you can write here FeNO3 whole twice. ठीक है ना? So this will have characteristics black precipitate. Black precipitate. ठीक है? So this will have characteristic black precipitate. So this is very important, and same reaction can also be done with number 2 if you use lead acetate solution. Just use lead acetate solution, FeS, then also PbS will be precipitated as black one, and along with that CH3COO whole twice Fe. ठीक है ना? So this is also black precipitate. So this PbS and PbS black precipitate तो होगा. So any one of the solution you can use to understand whether this is a sulphide or not. Whenever you give PbNO3 whole twice in FeS solution and you get a black precipitate, you are pretty sure it has to be a sulphide, and I have already given lead nitrate, so it is lead sulphide, right? So lead sulphide is giving the black precipitate. That means this anion must be sulphide, because only one compound of lead is having a black precipitate. So lead sulphide, this sulphide is coming from this compound. So I am sure whatever the sample is given to me is having a sulphide ion. ठीक है ना? Okay, clear? So and now see, I am going a little bit fast, because in the last video I went very slow just to give you the basic understanding how these tests are done. Now I am going fast because now you have the understanding. एक एक करके reagent डालना है और खत्म करना है. ठीक है? Okay. Next reagent in our list is chloride, right? Yes. Next reagent is chloride. So we are going to do chloride after this. So chloride radical. See, chloride radical means a simple compound we can take NaCl, है ना? NaCl we can take chloride radical. So for this, see, you have to find out a reagent which is going to give a precipitate with chloride radical, right? So anything that comes to my mind is AgCl. AgCl is giving an white precipitate with this chloride radical. That is, silver will give you a white precipitate with this chloride radical. So which reagent of silver we can use over here? So there is a very famous reagent of silver, that is AgNO3. AgNO3. So AgNO3 you can use with NaCl, and you will get AgCl plus NaNO3. ठीक है? This is white precipitate. Please also write soluble in excess ammonium hydroxide. Soluble in excess ammonium hydroxide. ठीक है? This white precipitate solubilizes in excess ammonium hydroxide, forming a very beautiful complex compound where the complex ion is like this. This is diamine silver ion. Okay? This is diamine silver ion. So this is getting formed, and after that it's becoming soluble. ठीक है ना? Complexation happens and it becomes soluble in NH4OH, excess NH4OH, remember it. Okay, so you have to write soluble in excess NH4OH. So a precipitate is formed which is soluble in excess NH4OH. ठीक है? So that is the taste of the chloride ion. Whenever I get this answer in chloride ion, I am pretty sure that this is the compound and the anion is chloride. ठीक है ना? क्लियर है? ओके. सो नेक्स्ट आयन इज नाइट्रेट. नाइट्रेट के लिए देखो बहुत एक आसान सा टेस्ट है. अगेन इट्स रिएक्शन वी आर गोइंग टू डू later on. It's a very famous test that we do in nitrate. So this is called ring test. Sometimes it is also called brown ring test. So what happens? First of all, in this case we add freshly prepared, please write down, freshly prepared FeSO4. ठीक है? Freshly prepared FeSO4 we add. Along that we have to also add H2SO4. So there is a simple procedure which I will read out to you. So first of all, what you need to do in case of nitrate is, to the salt solution in water, first you add this ferrous sulfate. First you add, this is the number 1. So, write here 1. How will you remember it? That is very important. Number 1 is, to the salt solution you will add this ferrous sulfate. Okay, and after that, drop by drop, number 2 you add this. There will be 2 layers formed like this. Okay, one layer like this. So, there will be 2 layers. Okay. So, let us take one layer like this and one layer like this, and in between them there will be a ring formed, and this ring will be of brown color, brown ring. Okay, this ring will be of brown color. This is called brown ring, and hence the name is brown ring test. Please copy this one. The diagram is very important, otherwise you will not understand if you don't study the diagram. Okay. Anything else you can do? You can also add, this is number 1 test, brown ring test. Number 2, you can also add concentrated H2SO4. Okay, concentrated H2SO4 to it, and what happens? You have to keep the temperature around 200 degrees Celsius. So, you need to heat. Yes, heat is important, and after this happens, a gas evolves. A gas evolves which has a little bit of reddish brown vapors. So, what happens basically, I will let you know. This H2SO4 reacts with this NaNO3 like this. Okay, and it forms NaHSO4 plus HNO3, and this HNO3 decomposes. Okay, this NaHNO3 decomposes to give H2O plus NO2 plus O2, and this NO2 gas is this reddish brown vapors. Clear? Eh? So, that is why you see this reddish brown. Directly this reaction does not give NO2. By the heat of the reaction, some part of the HNO3 decomposes. Okay, and it gives NO2, and that is why it gives. So, you want a balanced reaction for this. I think this will help you. Is it visible? Yeah, H2O plus NO2 plus O2. 4 NO2, here I will have to make 2 H2O. So, done. Okay, so as you can see, this will give you the reddish brown vapors. Clear? Eh? So, this is also an important anion that you need to finish, right? And another important is sulfate anion. We have not finished sulfate anion, right? Sulfate anion, SO4 2 minus. That is also very important. Okay. So, here number 1, you need to add BaCl2. Why we are adding BaCl2? First of all, this BaCl2 will give you with any sulfate. Let us take Na2SO4. Let us take Na2SO4. So, with Na2SO4 you have to now you will be very much conversant with the reaction after doing so many reactions. BaCl2 should give what? Double decomposition. So, 2 NaCl plus BaSO4. Now, this BaSO4 will give you white precipitate. Okay? This BaSO4 will give you white precipitate. This is even insoluble in concentrated HCl भी दे दोगे तो भी ये insoluble है. ठीक है ना? This will give you white precipitate, but concentrated HCl दे दोगे तो भी ये insoluble है. ठीक है ना? Okay. Next is, you can also add our next reagent, number 2 reagent is lead acetate. So, lead acetate, you have got fair idea what is lead acetate now. So, just add lead acetate, let us see what happens. So, CH3COO whole twice. So, what will happen? This lead is going to combine, this lead is going to combine with SO4 and form PbSO4. This is again will give you a white precipitate plus this 2Na, and so 2CH3COO Na. Okay. So, this PbSO4 is formed. ठीक है ना. This PbSO4 is formed. As soon as this PbSO4 is formed, this is an white precipitate, characteristic white precipitate of lead sulfate. ठीक है ना. So this lead sulfate, what you are seeing right now, will give you an idea. Must be a sulfate there, otherwise where from the this white precipitate is coming. क्योंकि सल्फाइड होता तो ब्लैक प्रेसिपिटेट आता, व्हाइट प्रेसिपिटेट आ रहा है, इसका मतलब तो आपका इसमें सल्फेट है. लेकिन PbCl2 का भी व्हाइट प्रेसिपिटेट होता है ना, PbCl2 का भी. लेकिन PbCl2 क्या है, थोड़ा गर्म कर दोगे PbCl2 तो दैट विल बिकम सॉल्युबल इन वाटर. तो जस्ट गिव ए हीट टू चेक वेदर इट इज PbCl2 और PbSO4. हीट करोगे तब भी इनसॉल्युबल है, इसका मतलब ये तो गारंटेड सल्फेट है. ठीक है ना. सो दैट्स ऑल अबाउट द आइडेंटिफिकेशन ऑफ एनायंस. ठीक है ना. So please go through this very well. Okay, identification of anions we have finished. Okay, we have finished identification of cations, we have finished flame test, but it is not the end of the story, because we have to also finish identification of various gases. We are going very slow in case of practical chemistry because this forms a huge amount of indirect and direct questions. So we have to go slow, but we have to keep everything in place. Okay, so identification of gases is still there. In identification of gases, we are going to study those reactions of SO2 and KMnO4, SO2 and K2Cr2O7, बड़ा reaction, but we will learn it mathematically. We are not going to learn it theoretically, याद नहीं करेंगे. We are going to learn it mathematically. याद नहीं करेंगे, याद रखना, याद नहीं करेंगे. We are going to do mathematics in chemistry. We are going to add and subtract and find out the reaction products. That's our motto, है ना. And the lastly, what else is there? We will study brown ring test along with its reactions in detail. याद नहीं करेंगे, रिएक्शन को समझेंगे, रिएक्शन का प्रोडक्ट निकालेंगे, हर रिएक्शन को समझेंगे, हर रिएक्शन का प्रोडक्ट निकालेंगे. ठीक है. एंड ऑल्सो वी आर गोइंग टू स्टडी सम थ्योरी ऑन इंडिकेटर्स. इंडिकेटर्स मीन्स there are certain things that is called pH that you have heard, right? You have heard about litmus paper. litmus paper आप एसिड में डाल दोगे तो क्या हो जाता है, रेड हो जाता है. बेस में डाल दोगे तो क्या होता है, ब्लू हो जाता है. ये क्यों होता है? What are the reasons behind it? We are going to do it. We are going to do it in this class only. Okay? So बहुत कुछ आने वाला है practical chemistry में. So stay tuned and please study this very well. Okay? Thank you.